Today's topic is Thevenin's theorem. Thevenin's theorem states that in any linear network or circuit containing several voltage sources and resistances can be replaced by a simple equivalent circuit containing a single voltage source and a series resistor. So in order to analyze this particular statement, let us consider an example. So this is the circuit which is given, and here we need to find out the current flowing through RL. Therefore, RL is considered to be as an load resistance. So here in this circuit we have a voltage source and a number of resistors. Therefore, this circuit can be represented as a simple equivalent circuit consisting of a single voltage source and a single resistor. So how to find out this voltage source and resistance is, we have few steps in order to find out the Thevenin's voltage and a single resistor which is known as Thevenin's resistance. So the first step is remove load resistance. Load resistance is nothing but the resistance through which we need to find out the current. As I want to find out the current through RL, I consider RL as load resistance. So first we need to remove the load resistance, that is nothing but RL. So the second step is calculate Thevenin's voltage. So how to calculate the Thevenin's voltage? We need to calculate the Thevenin's voltage across the terminals across which we have removed the load resistance, that is these two terminals. So when we want to find out the Thevenin's voltage, the VTH is in parallel with R2. So in a parallel circuit, the voltage remains same. Therefore, we can write it as VTH is equal to I into R2. So how to find out the current I? The current I can be found out by applying KVL, that is Kirchhoff's voltage law. According to Kirchhoff's voltage law, V is equal to the voltage drop across resistor 1, that is I into R1, plus the voltage drop across resistance 2, I into R2. Therefore, we get the equation of current as I is equal to V by R1 plus R2. Once we calculate the value of current, we can find out the value of VTH. After calculating VTH, the third step is to calculate the Thevenin's resistance. When we want to calculate the Thevenin's resistance is calculated across the open terminals, and if we have any voltage sources in the circuit, the voltage sources has to be short circuited, and if we have a current source, the current source has to be open circuited. So as we have a voltage source in this circuit, the voltage source has to be shorted. So when we short circuit this particular voltage source, now the resistances R1 and R2 are connected in parallel. So when these two are connected in parallel, the equivalent resistance R is equal to R1 R2 by R1 plus R2. After calculating R, the circuit reduces as R in series with R3. So as these two are connected in series, the total resistance RTH is equal to R plus R3. The final step is we have to draw the Thevenin's equivalent circuit. So the Thevenin's equivalent circuit consists of a single voltage source in series with a single resistor, that is VTH connected in series with RTH. This forms the Thevenin's equivalent circuit. After drawing the Thevenin's equivalent circuit, replace the open terminals with load resistance, that is RL. Therefore, the total current IL is equal to VTH divided by the equivalent resistance. As the resistors are connected in series, the equivalent resistance is RTH plus RL. Thank you.